All right, now we're ready to look at an example using the fundamental theorem of calculus to compute an integral. All right, so we want to compute the integral from 0 to 2 pi of sine of x. So let's just recall the fundamental theorem of calculus says the integral from a to b of a function f of x is equal to big F of b minus big F of a, where this big F function is an antiderivative of little f. All right, I think we're ready. So for us, we first need to find a big F, an antiderivative of sine of x. We saw in the previous video that an antiderivative of sine of x is equal to negative cosine. So this means our integral from 0 to 2 pi of sine of x dx is equal to negative cosine evaluated, let me put in that x here, negative cosine of x evaluated at 0 and 2 pi. So here is some notation that I'm using that you might not have seen before. So this notation tells us that we need to compute negative cosine of 2 pi minus negative cosine of 0. So this is just notation that again is telling us we're going to subtract this function when we evaluate at 2 pi, the upper bound here, and then at 0, the lower bound. So we'll see this a lot. It just helps to organize our work and to set up what that difference is going to start to look like. All right, so let's compute these two values. Well, we have cosine of 2 pi, negative cosine of 2 pi. Cosine of 2 pi is just 1, so when we negate it, we get negative 1. And then now we get negative cosine of 0. Cosine of 0 is also 1, so we get negative 1. So if we gather our negatives, we get negative 1 plus 1, which is equal to 0. Let's just check. Should this make sense? Well, this integral here from 0 to 2 pi of sine of x tells us we need to compute the area under the sine curve. Recall the sine curve starts at 0 and is cyclic, sinusoidal, it goes back and forth like this between positive 1 and negative 1. And then our horizontal axis starts at 0, pi, 2 pi, so every lump is a pi, 3 pi. So then the area from 0 to 2 pi is the area under this curve and the area under this curve. And now recall the areas in the negative direction of our x-axis are negative. And so we see that indeed sine is very symmetric. The area here is going to be equal to the area here. Since this area is negative, they're going to cancel each other out, and we're going to get a net of 0 area there. Awesome. Great work working through our first integral using the fundamental theorem of calculus. Now I think you're ready for some more examples.